Hello and welcome to today's geometry lesson. Today we're in chapter 6, lesson 3, and we're talking about medians and altitudes of triangles. So first of all, what is a median? A median starts at a vertex and goes to the opposite side's midpoint. So we're going to start by making a triangle here. And then I would like for you to grab your ruler and construct all three medians. So go ahead, stop the video, go ahead and construct all the medians here. So I'm going to pick the midpoint, and it goes from the vertex to the midpoint. Okay, so the midpoint, vertex to midpoint, midpoint, vertex to midpoint, and they meet at a point of concurrency, and the point of the concurrency that's made by connecting all of the medians is called the centroid. Okay, this is called the centroid. Now, my triangle here looks like it might be acute, but what do you think would happen if we did an acute triangle or a right triangle or an obtuse triangle? Where do the centroids meet? And all of them are in the interior. All are in the interior. And there's a couple special things that happens with a centroid. One of them is that this is called the balancing point. So if we were to cut this out and make these out of metal or something like that, and we were going to put a stick and balance it on a point, you could put it on this centroid and it will stay balanced wherever it was at. So if it got to be more of an obtuse angle, that point would move over. If this angle got bigger, like this way, then the centroid would move over here to where it's thicker a little bit. And it is always called the balancing point. So the centroid, all of them are on the interior, and it's the balancing point. Okay, I'm going to erase what I just drew here. So now our next thing that we're going to have you do is I want you to pick one median, one of your medians, and I want to measure from the vertex to the centroid, from the centroid to the midpoint, and then the entire segment. Okay, so this is the figure that I had. And let's see, this is the midpoint, the midpoint, the midpoint. Just draw this in here super quick. Okay, so here's the centroid. So I want you to focus on one. Just focus on one of your medians. And this is the vertex to the centroid. So measure vertex to centroid. And when I measured from my vertex to the centroid, I got 3.8 millimeters. And then measure from the centroid to the midpoint. So my centroid to the midpoint was 2 millimeters. And then obviously the whole thing, when you measure the whole thing, I'm going to end up with 5.8. So from the vertex to the midpoint, mine ends up being 5.8. Okay, so now what's happening here? So compare my numbers to what you got. Are you getting roughly the same thing? Now remember, there's always a little bit of human error. So mine, when I measured some things, actually I wasn't very super careful. I'm hoping you guys were more careful when you did this. And when you measure this distance, now if you picked a different one, what would happen is something like if this is 3, this is 6. So the whole thing is 9. So if we compare 3 to 9, that is 1/3. If you compare 6 to 9, that is 2/3. So the actual theorem that they say is always from the vertex to the centroid is always 2/3 of the whole distance. And then the centroid to the median is always 1/3 the whole distance. Now, most of the time, what you guys always tell me is that the centroid to the median is double whatever the centroid to the median is. So you see my data came out here pretty close. I'm off by 2 millimeters from that happening. Okay, so this was my 3.8 and this was my 2. So if you double 2, you get pretty close to 3.8. All right, so here's what everything looks like in a nice, neat, organized. So they always use the 2/3 part. So the centroid is located 2/3 of the distance from the vertex to the midpoint. Okay, so it's always from the vertex to the midpoint is always the bigger side. And then the shorter side is from the centroid to the midpoint. And like I said, normally you guys always use it in the fact of if I tell you PY is 4, you just double it and tell me that AP is 12. Okay, if you take 4 times 3, we get 12 to be the whole thing. Okay, what else is cool about this is that this median, I called it the center of, I didn't call it the center of gravity, I called it the balancing point. And so the center of gravity is another way of saying it. So that is the balancing point, the point where you could balance that on top of it and it wouldn't tip over. So this is called your center of gravity. Okay, centroid, made from medians. Okay, median start at a vertex and goes to the opposite side's midpoint. All right, let's see if we can do some sample problems. All right, given that RL, all right, so they don't tell me, is this the centroid? Is this not the centroid? What is this? How do we know if this is or is not the centroid? Well, what we do know for sure, what the heck's happening here? We do know for sure, oh yeah, for sure it's the centroid. Do you see how it starts at a vertex and it goes here? Is that the midpoint? Is this the midpoint? Is this the midpoint? So we do know without being told that this is the centroid because they are made from medians. So we have to know that right off the bat. All right, find LS. Let's see, RL, the whole thing is 21. 21 divided by 3 is 7. So RS is 7, and this must be 14. All right, then NQ, let's see, SQ right here, they tell us is 4. So double that is 8. So NQ must be 12. And you can certainly take the shorter part and just times by 3 and get 12. All right, next one. Given that D is the centroid, so they're telling us this time that it is the centroid. DF is 4x minus 1, and BD is 6x plus 4. All right, so is this point cutting this in half? Can we just say 6x plus 4 equals 4x minus 1? Are those equal? And the answer is no. Remember this one, the smaller one, it always is twice. If we multiply this one by 2, we get to the other one. So 6x plus 4 is 8x minus 2. So what do we have? 6, so if I add 2, subtract 2x, 8x minus 6x is 2x. Let's divide by 2. And so x is 3. All right, they don't ask us to find anything else. All right, so that should be wrapping it up the centroids. Now we have one more that we need to go over. All right, so this one, making a triangle, and we have to check out the scalene, the obtuse, and the right triangles, okay? Oh, and acute. So where do they meet? Okay, so this first one is our acute. And what we're doing this time is altitudes. So altitudes are similar to when you find the height of a triangle. So if we look at this and we wanted to find the area, what they do is they typically tell us the height of this. So it starts at a vertex and goes to the opposite side perpendicular. And we often call that the height of the triangle. Okay, so now if we do another one, we could have gone from this side and made that perpendicular, and we could have gone from this side and made that perpendicular. So these are making the altitudes. Altitudes. Okay, the altitudes start at a vertex, and this time they go perpendicular to opposite side. The medians. So the median started at the vertex too, and they went to the midpoint. Altitude start at the vertex, but they go perpendicular to the opposite side. So in this one, you can see that that point of concurrency is inside the triangle. Okay, so let's look at the right triangle. Start at a vertex, and then the opposite side is going to be this one right here. Well, if we go to the opposite side, isn't it actually the side itself? And if we start at this vertex and go to the opposite side, so start here at this vertex and go to the opposite side, that one is this side. And now in the last one, if we start at the vertex and go perpendicular to the opposite side, where did all of these points meet? So if you have a right triangle, where do they all meet? At the right angle. So remember, the circumcenter met at the midpoint of the hypotenuse, and this one meets at the right angle. So now if you guys think about your obtuse triangles, and this one's a lot harder. So if we're going to do the altitude, it starts at a vertex and goes perpendicular to the opposite side. All right, that wasn't completely straight. Okay, so the hard part here is we have to, if I start at this vertex and I want to go to this opposite side right here, what happens is I need to extend that side so that I can get this to be perpendicular. And then if I'm going to start at this vertex and go to this side, I need to extend it so that I can come down perpendicular. And you'll see my original figure, this is my original triangle, was obtuse. And what happens here is that altitude, which is called the orthocenter, the point of concurrency made by the altitudes is called the orthocenter. And you can see if it's an obtuse triangle, it's outside. Now, as we make this angle closer and closer and closer to a right angle, this point comes in, and that's what eventually, if it's a right triangle, it gets on. And then if this angle becomes acute, then it becomes inside the triangle. So the orthocenter has 3 meeting points for this. So the orthocenter basically is called the altitude, which also can be called the height of a triangle. Okay, it starts at a vertex and goes perpendicular to the opposite side. And if it's acute, it meets inside. If it's obtuse, it's outside, and it meets on at right angle. So be specific. Don't just say on. It actually meets at the right angle. Okay, if you need to, stop it and copy down your information. All right, find the coordinates of the orthocenter. So we need to start at the vertex and go perpendicular to the opposite side. So we know for sure the way that this is drawn, the way this is, the altitude here to perpendicular to MN is going to have to be this blue line right here. Okay, so we know for sure it is going to do that. So that is the altitude from L to MN. Now we need to find another one. So we can either start at M and go perpendicular to the other side, or N and go perpendicular to this side. It doesn't matter which one we do. So if we just start at M and go perpendicular to this other side here, what we need to do is find out where these are meeting, okay? And it might meet at a nice, neat point, and it might not.